Hi friends, this is the first lecture in the lecture series for the preparation of GATE in mechanical engineering. Please note that this entire lecture series will be only for the preparation of GATE, but the concepts will be well defined. So in this lecture we will be dealing with the heat transfer, various modes of heat transfer and steady state one dimensional heat conduction also. So we all know that heat transfer is occurring in basically in three modes. First one is the conduction, second one is the convection, and the third one is the radiation. Okay, and let's deal with the conduction. In conduction, consider a material medium, consider a body in which let's suppose 2 points 1 and 2, and this point 1 will be having a temperature T1 and this point 2 will be having a temperature T2. So in this, because of the presence of this temperature difference, heat will flow from high temperature to low temperature. So in this case, if T1 is greater than T2, what happens is that heat will transfer from point 1 to point 2 in this direction, and if T2 is greater than T1, heat will transfer from point 2 to point 1 in this way. And the law which governs this heat transfer mode, which is the conduction, is the Fourier's law of heat conduction. It simply says that heat transfer per area will be equal to minus k dt by dx, and this q dot is the rate of heat transfer, and this a is the area of heat transfer, and this k is the thermal conductivity of medium, and this dt by dx will be the temperature gradient. So this is the equation that governs the conduction mode of heat transfer. So then let's deal with the convection. In convection, suppose consider a body or a wall which is having a temperature Tw, and suppose a fluid is flowing over the body at a temperature T infinity with a velocity of V infinity. If Tw is greater than T infinity, heat transfer will occur in this direction. Okay, and suppose if T infinity is greater than Tw, what happens here is that the direction of heat transfer will be reversed, that heat will transfer from the fluid to the wall or the body, and the governing law behind this method or mode of heat transfer is Newton's law of cooling. Newton's law of cooling. In this, it states that heat transfer per unit area will be equal to H into delta T, where Q dot is the rate of heat transfer, and this A is the area of heat transfer, and this H is the convective heat transfer coefficient, and this delta T is the temperature difference. In this case it will be Tw minus T infinity. Okay, so this is the law which governs the convective mode of heat transfer. For the radiation, what happens here is that suppose two bodies which are placed in this space, and what happens is that these two bodies will emit radiations, and in this radiation concept we will be considering only thermal radiations. Okay, so what happens is in this thermal radiation or this radiation concept is that the heat transfer will occur in form of electromagnetic waves between the bodies that are not in contact between them. So the law that governs this mode of heat transfer is Stephen Boltzmann law, and in this heat transfer per unit area will be equal to sigma into T raised to 4, and this sigma is the Stephen Boltzmann constant. This T is the temperature of body. So you know that Q is the heat transfer rate, and this A is the area of heat transfer or the surface area of the object. So these are the three modes of heat transfer.